Welcome to question 4 on the 2023 graphics paper. So part A, shown below is a garden lantern. In the space provided, draw a well-proportioned freehand sketch of the elevation, looking at the lantern in the direction of arrow A. So elevation looking here, not a 3D view this time. So we have our base here, which is what we're going to see this rectangular outline. So I'll draw. It's a freehand sketch now, we can't use our drawing equipment, so here's going to be my base rectangle. Okay, so that's that rectangle. Then we have this square, it looks like a square to me anyway. So I'm going to come in a little bit and equal the distance on this side, and that's going to be the length of my square. So vertically up, about that width. Distance, yeah. So here's my square, and then we got this pyramid at the top, so that will appear as a triangle. So coming up from the middle, up there. Okay, that will be our top, and then finally we've got this circle. Okay, which isn't quite actually centered. There's a bit of a bigger distance there than there is there, so it'll be kind of there to here. That's our center, our diameter. So I'll go across there just to find the diameter there and there, and let's draw a circle as best we can. Okay, so I'm happy enough with that now, and so I'll go around everything heavy. Sure. All my horizontal lines are parallel to each other. My vertical lines are parallel to each other, and everything is well proportioned. There's consistency in our drawing there. Okay, and they haven't asked us to shade or render anything or color anything, so we're happy with that. Okay. Shown below then, part B, shown below is the outline drawing of a bulb to be used in the lantern. Using the dimensions given, complete the drawing of the bulb on the given center line to show all construction lines and points of contact. So we've got our little base part. We'll start by drawing this little rectangle. Okay, and we have the width of that rectangle. So I'm going to measure up 15. That's my rectangle. Like so. Okay, that's my rectangle. Then to find the center of this arc, I'm going to go straight out 45. I'll do that on both sides. So 45 out from here. Okay, so make sure we're not going from the center line, we're going from the edge there of our bulb. 45, we'll do the same the opposite side. 45. Okay, so compass set to 45. Okay, so it's going there somewhere, and we'll do the same on the opposite side. Okay, that's bigger than I need it to be, but we'll see why in a second. So now we want to find the center of this circle. Okay, we know its radius 35, but they haven't told us how far up to go. So we need to start thinking about what we do know and what we do have. So if I was to draw a straight line from this center to this center, it would be 45 to here plus 39, sorry, 34, which in total is 79. Yeah, which in total is 79. So I'm going to get my compass and set it to a radius of 79. Exactly 79. And from here I can swing an arc. Now we have a center line, but if we didn't, we could always find the center, find that point, swing it from both sides. So here is my here's my center of this circle. So let's set it to radius 34. Done all this accurately, then it should touch perfectly off of that arc. Perfectly off of that arc. Okay, so that is that drawing complete, but they want us to, should I just roll out that because I've gone a little bit too long with it. Okay, what they want us to do here is also show all construction lines. So I've shown all construction lines there and points of contact. So we've got a point of contact here between this arc or this circle and this one as well. So I'll locate the point of contact is I join the centers. Join the center. Okay, show that a little bit clearer. So where they join, here and here, that's a POC, point of contact, POC, point of contact. And technically this is a tangential line to this arc, so I might as well just to be sure POC, and there POC. Not sure what's required in the marking scheme, but no harm in showing it. Okay, so that is question B. Question C then, shown below is an incomplete perspective of the drawing of the lantern without the circular window. Okay, so we're forgetting about the circular window here. Don't worry about it. A 3D graphic is also shown. Complete the perspective drawing of the lantern. So we've got our vanishing points, we've got our horizon line. Okay, we'll start at the bottom and work our way up. So they've given us the height of that rectangle, so they've given us this little height here. So we just need to vanish back to VP1. So we hit that point, and we'll vanish. That one, the base is already vanished there, so we'll vanish the top height back. And we can draw our vertical edge, okay, and then we also have this line and this line, those two back lines, so they want to vanish to VP1 and vanish to VP2. So VP1, show that extend through, and VP2. Okay. Next up, we want to draw this kind of square. Sorry, is it a cube? Maybe it is, I'm not sure. But we have the height of it. Okay. We know the edge is going to be at this point. Let's just first of all draw that vertically up. Vertical lines stay vertical, and then we're going to vanish forward from this corner. Okay, and I can vanish this corner forward as well. And here's my edge. Okay, and then finally I've got that part. They've given them to us. We just need to draw in the last little bit of the pyramid roof. So there we have it. That's question 3, and no coloring or anything needed there. Right, or part C. Part D, shown on the right is the roof of the garden lantern. The roof is based on a square-based pyramid. Shown below is the elevation and plan of the roof. So we've got our elevation here and our plan here. Complete the indexing of the elevation from the given plan. So we've got our points here. And I'll actually do it in 3D view just to help us. So we got A, D, top is O, C, and B. Okay, so we're looking down on top there, left eye, right eye, and we're seeing that. So looking in here now from A, or from this direction for our elevation. The very top is going to still be O. Okay, if I'm looking in here, I've got D and A are in line with each other. So that's D and A comma D. And looking, we got C and B, so B comma C. And you can see there, they're in line with each other. That's in line. So that's our indexing. Find the true length of line OC. So here's line OC. There's line OC. So if you imagine here, line OC, it's sloping up towards you, okay, in the elevation, or in the plan view. In the elevation, it's actually sloping out, kind of like this, in this direction. So what we want to do is we're going to rotate it around to that position, so that when we look straight in at it, we're perpendicular in the plan, or in the elevation. So just rotate it around until it's in that position. So here's point O, C, rotate it to there. So that's my new position for OC. I'll highlight it there in yellow. Okay, and we're going to project that up. Right, the height of C hasn't changed, it's just rotated, so it's gone from this position, rotated, gone from this position, sloping towards it, rotated around so that we're perpendicular to it. So that is my new C. O is still in the same position. Use my yellow to highlight that again. Okay, so that's true length. Okay, so that's question D completed there.